This video is an introduction to probability. Before we get started, we should define a few terms. So the first of which is experiment. So when we talk about probability, we often talk about some kind of experiment that's happening. So in this case, as an example, an experiment might be the flipping of a coin. So that would be the experiment. The outcome, or the outcomes, are all possible results of an experiment. So in the flipping a coin example, we could flip a head or we could flip a tail. So those are all of the possible outcomes. When we talk about an event, we're talking about the desired outcome. So if we want to flip a coin and find the probability of getting a head, then the desired outcome is getting a head. And essentially what we're trying to do is to figure out how many ways we can do that. The probability of an event varies between 0 and 1. An event that has a probability of 0 is considered impossible, not going to happen. And an event that has a probability of 1 is guaranteed to happen. We can define technically probability as this formula right here. It basically just says that the probability that A happens, so probability that A happens, sometimes we just say the probability of A for short, is equal to the number of ways that A can happen. So this N here just means the number of elements in this set A. So this is the number of elements in A. And we divide that by the number of elements in S. So S is that universal set, the all possible outcomes. So this is the total number of outcomes, we'll call it. So total number of outcomes. And we always define probability this way. So anytime we try to find the probability, we're always looking for the number of desired outcomes divided by the total number of possible outcomes. So in the flipping the coin example, if we're trying to find the probability of getting a head, there's one head. There are two possible outcomes, so the probability of getting a head is 1/2, or 1/2. All right, let's look now at some examples. So in this example here, we want to find what is the probability of drawing an ace from a deck of cards. So a deck of cards has 4 aces, so the number of desired outcomes. So the outcomes in this case are the actual aces. There are 4 of them in total. The total number of outcomes is equal to 52, since there are 52 cards in a deck. So then the probability of A happening, the probability of getting an ace, we might even write that in here just as a reminder, or we can just leave it like this. So the probability of getting an ace is equal to 4 out of 52. Now we should reduce this fraction to lowest terms, and in this case we can divide both the numerator and the denominator by 4. So we should go ahead and do that. So 4 divided by 4 is 1. Oh, wrong color there. And 52 divided by 4 is 13. So the probability of getting an ace is 1 out of 13. So that's basically how you do probability. There are a few other things to worry about, and then obviously we can get much more complicated. So the idea here of an event A not occurring is this right here. So we use this this little apostrophe basically means the complement of A, and that just means the opposite of A. Complement of A. So this is the probability, this right here is the probability that A does not happen. So probability of A not happening. And the probability of A not happening is just equal to 1. Remember, that's the greatest probability that we can have, minus the probability that A occurs. So the probability that A doesn't occur is 1 minus the probability it occurs. So for example, if the probability that it's going to rain tomorrow is 40%, we can write that as a decimal as 0.4. And the probability that it's not going to rain is just equal to 1 minus 0.4, which would be 0.6. The other way that we can look at the probability of A not happening is by actually going back to the definition of probability. We can find the number of ways that A doesn't happen and divide it by the total number of outcomes. So that's two different ways. Oftentimes we talk about three different types of probability. There's empirical probability, so that actually comes from an experiment. So the key here is that you have to do an experiment. There's theoretical probability that's calculated. So we can say, for example, that flipping a coin, the theoretical probability of getting a head is 1 out of 2. There's one head and 2 possible outcomes. But if we did an experiment and we flipped a coin 10 times and 6 of those times we got a head, then the probability here would be 6/10. That's the empirical probability, which is the same as we could either reduce that to 3/5 or just turn it into a decimal here. So the probability here is, maybe I should put the 3/5 in here just to make it look a little tidier. So that's an example there of empirical probability coming from an experiment and actual theoretical probability, what the answer should be. There's also something called subjective probability. That's more like a gut feeling. So, what do you think the probability is that you'll get a good night's sleep tonight? Or what do you think the probability is it's going to rain tomorrow? You might have a guess at what that is without a lot of data to back it up. So that's what we call subjective probability. All right, let's move along here, and we'll do a couple of examples. So here's an example where we're going to roll 2 dice, and it says, what is the probability of rolling a sum of 8 when rolling 2 dice? So what I've done here is I've listed all of the possible outcomes we could get. So here's our first die at the top here. Our possibilities are 1, 2, 3, 4, 5, and 6. And along the bottom would be the results from our second die. So we could get all of these things. And when we add the 2 dice together, so here if we got a 1 and a 1, we'd have a total of 2. If we had a 4 and a, let's say a 5, 4 and a 5 would be a total of 9. And so this chart just shows you all of those different possibilities. All right, so the question here said, what is the probability of rolling a sum of 8? Well, here are the sums of 8. We can actually count them, circle them. It's important to realize there are lots of different ways to get an 8. You can see in this table is actually quite important when we do probability questions because it helps us see all the different ways that we can roll the dice and get the different sums. So you can see that, for example, a 12 is much less likely than rolling an 8, for example. All right, so let's go ahead and do this question. So the question says, what is the probability of rolling a sum of 8 when rolling 2 dice? Well, the number of ways that we can get an 8, number of ways that desired outcomes are equal to 8. The total number of outcomes, so the total number of ways that we could roll 2 dice, is just how many entries are in this table over here. So it's the table is 6 by 6, so there must be 36 possible outcomes. So the probability of getting a sum of 8 is equal to 8 over 36. And again, we should reduce this fraction. We can divide by 4 for sure. And we divide by 4 and we get 2/9. So the probability of A is 2/9. So therefore, the probability of a sum of 8 is 2/9. And again, one of the things that I did kind of mention briefly earlier is that we can actually represent or express our answer as a fraction. But we can express it as a decimal as well if we wanted to. So probability is sometimes expressed as a decimal. So we just convert that to a decimal, 2/9 to a decimal, by dividing the numerator by the denominator. I'm just going to add that in here because sometimes you do see it expressed in both ways. So 2 divided by 9 gives us 0.22. And then we can also express that as a percentage, which would be 22%. So 3 different ways to express the probability. Again, important to remember that, well, just that you can see it in different ways, and if you need it in one of the other ways, then you can convert that. All right, let's look at this slightly more complicated example here of flipping a coin and then rolling a die. So you're going to flip a coin and you're going to roll a die. The question here is, what is the probability that you flip a head, then roll a 4? So you can start to see here that counting becomes important. We want to count the number of ways that we can flip a head and count the number of ways that we can roll a 4. And we want to be able to do both of those. So a tree diagram can be very helpful here. So I'm just going to create a little tree diagram off to the side here so we can count of all of our outcomes. And that's sort of what we did up here with the dice. We had a table that listed all of the possible outcomes, which made it really easy to count. So here are the possibilities when I flip a coin. I could get a head or I can get a tail. And if I get a head, when I roll my die, I have the option of getting a 1, a 2, a 3, or a 4, a 5, or a 6. And then when we do the tail, sorry, I'm just going to move my tail down a little bit just to have a little bit more room. When we do the tail, we have the same possible outcomes when we roll our die. So again, we can have a 1, 2, 3, 4, 5, or 6. So we can go ahead and count now. What is the probability that you flip a head, then roll a 4? So we're looking to flip a head. That happens here. And then rolling a 4. So there's only one way that happens. There's only one way to get a head and a 4. There's that possible outcome right there. So in this case, the number of desired outcomes, I'm actually going to write it in here. Sometimes it's helpful to write in what it is you're finding. Number of ways to get a head and a 4. And that way you don't forget. We said was 1. The total number of outcomes. Total number of outcomes. Now we can use our counting technique here, the fundamental counting principle. There are 2 ways to get a head, 6 ways to roll the die, and we get a total of 12. Or you can count the branches on the tree, 1, 2, 3, 4, 5, and 6, and another 6. Sorry, that looks like an 8. Let me fix that up. That was an S that went wrong. Let's fix that up. So we have NS here, we said is equal to 12. So the probability of getting a head and a 4 is equal to NA over NS, just as a reminder. This equation is crucial when we talk about probability because this is how we find probabilities. The hard part is just finding out what NA is and what NS is. So in our case, the number of desired outcomes was 1 and the total number of outcomes was 12. So then we can finish that off with a statement. Therefore, the probability of flipping a head and rolling a 4 is 1/12. So that's the basics of probability.